Good afternoon, everybody. So my name is Markus Kogel Hollacher. I'm doing some presentation this afternoon for the partner Precitec, and as you see here in the headline of my presentation, our job, at least one of our jobs in custodian, some of our jobs or tasks have been presented before. That's why I concentrate on our task, which is related to laser beam cutting. And my presentation covers some information about why we intend to use the expertise of the custodian partners to improve laser cutting. As you may know, Precitec, we are an international operating company with about 600 people working worldwide. So we are not small anymore, and we are not an SME anymore. But nevertheless, if you see Gaggenau, our headquarters in Gaggenau, the main division and the main work we perform in Gaggenau is related to laser cutting. So it's about, I would say, 70% of our revenue is still in laser cutting. Even though we have welding, even though we have sensors for both applications, for cutting and for welding, cutting heads is still very, very important. And what is important for us definitely is to improve the cutting process, to improve our tools, to improve the cutting heads. And you see here some more stuff Precitec is working on. You can easily go to the www.precitec.com webpage and inform yourself about the divisions and sensor technology and all the stuff. I would go into the cutting. And the idea is to improve cutting with 1 micrometer lasers. Precitec was founded in 1971, quite some years ago. And actually, at the early beginning of Precitec in the 70s, the company started to work with laser cutting. And for those who are familiar with lasers and laser technology and the history of lasers, they know that these days, the typical laser, which was used for more or less everything, was a CO2 laser. And so Precitec had CO2 laser cutting and sensors to do the distance control in laser cutting, but all in CO2. And as about 15 years ago, fiber lasers, 1 micrometer lasers, put it like that, these lasers came into industrial applications, came into the mind of people who did plan laser applications. People started to try to use that lasers for cutting as well, and they directly have investigated some problems, really severe problems in the quality. And so a long time, 1 micrometer lasers and CO2 lasers run parallel, but as the 1 micrometer lasers become cheaper and cheaper nowadays, that lasers are the work horses more or less in laser cutting as well. But we are still working on the improvement. And as you see here in my headline, there have been some approaches to improve the laser cutting process, on the side of the laser source, also on the side of the processing head. And we in Custodian, we're using a new approach. Gwen already explained the MPLC system. This is a new idea of doing beam shaping. Why is beam shaping important? You see our portfolio in laser cutting is quite big. What you see here is just 1 remaining cutting head in CO2, but the rest is all done for 1 micrometer lasers. And what you see as well is that if you go on Google and just print laser materials processing, you will easily find Precitec components displayed in all the pictures. So we have a worldwide reputation. That's why we need to take care on improving our tools. And let's go to the next. So this is the state of the art we are talking. That was too fast. what we are talking right now. I hope the video starts. So this is Hans laser working with Precitec cutting head. This actually is the cutting head which we use in custodian as well. You see cutting processes on different thicknesses, sheet thicknesses, all with 15 kilowatts laser power. And you see that the thicker the material gets, the slower the cutting process is going. What we don't see here is the quality of the cut curve. This is a high-speed cutting process here with a light cutter. This is an industrial application as well. So it's very, very fast nowadays what cutting is going to be. But here on this slide, you see the trends we are facing. The trends we are facing is on the side of power levels. So we now have customers who want to put 30 kilowatt lasers onto a Precitec cutting head in order to maybe cut 130 millimeters of steel thickness. And you see that there are some very, very nice indications of which laser source you use, which is just visible for the expert. But you see more or less on the cutting curve if you use a CO2 or 1 micrometer laser. And so our demand is to stand high power. Our demand is to get thick sheets cutting with a high quality. And our demand is also on automation of our tools, which means in our case putting sensors as much as possible into our cutting heads nowadays by using the Bluetooth technology to communicate with any kind of device with the cutting head to see the actual status with respect to temperature, with respect to contamination of optical surfaces, and so on and so on. And as we have seen in the past, that there have been some approaches on modification of the beam or the power distribution on the workpiece. You see, these were the first steps actually with Trump using the bright line fiber technology, correlates, which is a part of coherent, using arm lasers, which are actually 2 lasers which can individually be controlled with the laser power. And the first ones more or less were Armada with their Enzys approach, where they did some changes in the in-coupling device to couple in to the fiber end. And this, in fact, changes the power distribution on the workpiece surface. We, together with others who don't manufacture laser sources, we need to do the modifications on the side of the processing head. And you see, we are not alone in that area. So Hayek, Air Liquide, Mitsubishi, or also Armada, they all are partners, competitors on the market, which try to do some modifications of the optics inside the processing heads in order to do some modification of the beam on the workpiece surface in order to increase the quality. And also there have been some modifications with respect to using dynamic tools, or in that case here, it was a Fraunhofer IWS, which started to combine a ScanLab scanner with one of our cutting heads in order to very fastly move the laser spot and to make it so-called static beam distribution. It is not really static, but it's very, very fast. So for the process itself, it seems to be static, and they could try, because using that galvo scanner, you can individually shape more or less your beam power distribution. They tried out some very fancy beam distributions which will not be tested before. And all that, the laser source, the approaches in the cutting head, or that approach here by IWS, made us aware, us as a custodian consortium, if we shape our laser, if we go and work on new ideas on shaped laser power distribution for specific applications, we need to go into laser cutting as well. And this is what our approach actually is in Custodian. We combine the MPLC system from K-Labs with one of our standard cutting heads, and we select different shapes of our laser in order to investigate the effect of that shapes on the process. And we are lucky that Yannick Lind, my co-worker in the project, one of my co-workers, has the possibility to work at the University of Stuttgart in order to do X-ray images of the laser cutting process. So what we do, as Gwen already said, in September, we will start in an X-ray chamber to prove the applicability of our shape, which we have decided on together with K-Labs and the custodian partners, and to prove that use of that shape by really going very, very deep into the process by looking through the material into the cutting curve. And you see, this is one of the works of Yannick in his PhD thesis. Based on the grayscale he can extract from these videos, he can simulate the cutting curve. He can simulate the geometry of the cutting curve. And so we can directly, if we switch on or off the MPLC, we can directly see the benefits of beam shaping in laser cutting. So last slide for you this afternoon. And by that, I thank you all for joining our webinar. So we see that for our task, for one of our tasks in Custodian, there is a trend in laser cutting which is asking for higher power, higher speed, and higher quality. And we see we can match these trends, the ideas of our customers, only if we shape our laser beam. This is not only true for thick sheets, this is also true for high-speed thin sheet cutting. And the custodian investigation is to combine MPLC with the state-of-the-art cutting head and to really look into the process and to further increase quality and speed. Thank you very much for your attention.